Hello everyone, welcome back to Hyperflex Huddle. I am your host Parivesh, and we are huddling back again to bring you the latest insights and trends directly from the Elastic expert. We have seen Elasticsearch as a search engine, we have seen it as a database as well, but how does it look like as an AI-centric system and how Elastic evolving itself into an AI-centric system? We're going to talk all this into this session. And to simplify this for all of us, we have a very special guest with us today, Mr. Sauhard Joshi. So welcome Sauhard to Hyperflex Huddle. We are really excited to have you here.
Hi Parivesh, thank you for having me at the Hyperflex Huddle, and I am very intrigued to be with your team. And today we are going to unravel and speak very candidly about the Elasticsearch and its applications in certain areas where I have the experience. So, introducing myself, I am basically a senior data architect with an experience with data science. I am completing my MTech in AI and ML with a specialization in natural language processing and deep neural networks. So, my core area of expertise is under the conversational AI, which is one of the most hot topics right now in the industry regarding your RAG and how a conversation is basically helping the system to give you the value out of it. And the AI is the backbone of it, and the Elasticsearch, it's the main brain of the complete setup. So yeah, that's in short the introduction for me.
Yeah, it's awesome. And I think you have been working with Elastic for a very long time now, and you have seen it evolving just from the search engine to what it is doing right now as an AI system. So, yeah, but before like moving into directly into the conversation, I would like your journey with Elastic to be briefly tell to our viewers right now. So, can you tell us your journey with Elasticsearch from the scratch and
Okay.
right now?
Okay, so this is very, I would say that a very unique journey. I started out as an instrumentation control engineer, completely working into the oil and gas. And a friend of mine, he was working with Elastic for a long time. So I had a keen interest in data because at that point in time, the energy sector was evolving with a lot of data being generated everywhere, and there was not many places we can load it and explore the data on it. The best tool that we could get is was one of the business intelligence tools, but the real time analytics is one of the areas which we're looking for. So it started up as a hobby project. It was not my mainstream work, but during the COVID time, I think I got some, like, before that, 1 year with my friend. On the weekends we started exploring it, how we can build some solutions around it. And but then I transitioned into completely into data engineering. And since I had a keen and a knack for it, so I started using Elastic around version 7. So from version 1, Elastic was a full text search engine. Then around version 5, it started developing the analytics and aggregation capabilities. With the version 7, it brought the ML anomaly detection in it. And then version 8 is the vector search plus semantic AI. And the version 9, which is the current version, that is basically powering your agentic AI platforms. That is your streams, agentic builders, and MCP servers. So yeah, so our first project that we tried was on the energy sector, and energy sector people should understand that, like other sectors, you have your data on the cloud. Energy sector, most of your clients will not allow the data to remain over there because that's quite a proprietary data and a data set which is they want to keep secured. So Elastic as a service, it can be run on Dockers or as a service in your VM environment, and you can keep your data close to yourself without exposing it on the internet. So yeah, so that was one of my first projects where we aggregated the data from multiple sensors. We simulated a lot of data using Python, and we built dashboards on top of it, did the anomaly detection. And then my real project, once I joined my team, it started it up with the telecom projects, where telecom we were doing a lot of real-time analytics based on the infrastructure and the data sets. But yeah, the majorly what I did is on the energy side.
Right. So yeah, it's kind of a very niche and a very good use case of Elastic. Can you draw a difference between how it looked like when we were working with around Elastic version 7? Let's say we are talking about data engineering, data analytics point of view. So with the release of the latest features like streams and as you mentioned, agent builder and all. So agent builder is mostly focused on our conversational AI chatbots and all. Streams is actually very focused on unifying the data sources and how it completely redefining how you source your data from your sources and put it into Elasticsearch. So can you plot a difference between how it was when it was around Elasticsearch 7 and how it has changed with the introduction of streams? We can say how it is changing for in terms of unifying the data into Elasticsearch and what were your impressions and thoughts when you first come across the streams and what are the things that you like, what are the things that you don't? If you don't like something, we can frankly say that, but yeah, what are your impressions when you first come to know about this?
Okay, so version 7. So in my current project, we have like from version 7, the clusters till version 9. And version 7, I would say that I've used couple of data platforms till now, and Elastic has been like one of the most easygoing. Like people know vibe coding right now, but I would say that with Logstash, you actually do some vibe coding, but not at that level like how the code builders like Claude and Codex are doing. Not like that, but yeah. Uh, Logstash as a real-time stream integrator, it was quite easy. You define your inputs, your filters, and then your outputs. And in version 7, we were just exploring how much data we can put and what was the architectures on the ingestion side. Now, when our database, our setup was done properly, so then we start exploring, like as any normal user will do, like how to handle that data set. Okay, because the real-time data set, if you have like around if I tell you like you have like 100 wind farms and you have your IoT setups over there, so if you're logging at 5 seconds, you get a log at every 5 seconds. So those are like you can just do the math and see how much data you are writing per minute or something like that, and you just keep your data because these data sets are for asset management. So what it does is basically you have a lot of things which are happening in the past, maybe some gear issues, because these are mechanical devices. They don't fail immediately, but yeah, you need to know where those spikes are in your data set to just to identify the problems where they are going. So to keep a data of about 30 days, 90 days, and when it starts growing up in your data set, you need more horizontal clustering and more data nodes to build around that. So that is where we started thinking, okay, what else we can use to do this? But with version 8 and 9, we understood that there are TSDBs, TSDB facility is there, logDB, where you basically compress the logs to a certain ratio, which can free up your pipelines, free up your disk and all that. And then we started implemented data tiering as well, like your hot warm cold architecture. Our memory started becoming more efficient because if like in the hot you need more RAM compared to the warm or cold architecture because you need to put a lot of data in memory, and that's how things moved on. And let's talk about Logstash because that's one of my favorite tools to use. If you have worked with other scheduler programs where you need to do the Python coding and you build that DAG graph, you will understand that it takes time to build things, and those are like running on the scheduler and bringing in that data. If you use Flink, it's a different story. Still, you use Python to build up your pipelines. But when it comes to Logstash, things are very smooth. Out of the box, you get a lot of things in your hand to do. And they have thought it well that what exactly their users need and how they want to parse the data. Mostly, we used to use the grok filtering, get all the grok data done, all the patterns done, basically, and parse all the data, store it in our different indices, and start building on top of it. But now, when you comes to stream, see if we have like 64 grok patterns today, and you have streams with you, now you can basically do that vibe coding thing on top of it and get that parsing done automatically. And then you just basically once you have the logic, you go into the grok parser and on your dev tools and basically check if your parsing is correctly being done. That's just a check on the top, but mostly it works out of the box. So yeah, so your your time to basically execute, implement your experiments, and to find the insights out of it, and see it at a production level, it has reduced by a good amount. And the headroom that you get out of it, you can basically try to use it somewhere. I'll take one more minute and I'll give you one more exciting thing about Kibana. Like today we have like Elasticsearch, we are talking about it. So Kibana as a dashboard, when we used to have incidents, we used to mark the incidents at version 7 or 8. I don't know when I started picking it up, or maybe at 9. I'm not sure when that feature was introduced, but now it is like one of your most important features for us. That is like if you have like 100 services which are running at the background, and there is some, then you have your logs and you have a log status. Like the log status can be an error warning, something like that. Okay. So when my operations team is looking at the data today, that they, back in those days, they have to go through each and every log to understand where exactly the error has happened. Now in your particular timeline, you have that particular thing mentioned over there where the error occurred, which service has gone down, at which time in your at which time it went down. And if you use your elastic, basically the AI assist on top of it, you can exactly know what is the cause if you have the right knowledge base at that point built with your system. So yeah, figuring out, doing the root cause analysis, now it has become much easier compared to, like, you have your personal chat GPT sitting with you, and you can, even because chat GPT nowadays they don't do dashboards, but now you have a Kibana on your side, you have your all your dashboards open beautifully in front of you. You have an AI assistant which is telling you what is exactly happening, and the operations team and the users, they feel more confident about their data. Yeah.
Right. So I think, yeah, you have mentioned it you say very rightly, very correctly. And AI assistant was actually a very breakthrough kind of feature that they have introduced, especially when you talk about the security incident management. The AI assistant is doing a really good job. And I was with the introduction of Playground. If you have tried that, now Playground is a one step ahead. It's just like you can talk to your data. You put it your index into the Playground and you can just start chatting with your chatbot. Okay, just explain me my data. You can ask any questions. And then you don't need to configure anything. It's a enterprise, so you can say feature. You can just drop down. You can select which indices. It's just like mentioning an index pattern. You can just mention your indexes, and you can start chatting with your chatbot regarding the data. So it will have that data in its context. It won't like, because it won't have much, you don't know much about outer world. It will give you the very specific answers regarding your data too. It's also a great thing that they have done. And I would also like to take a minute to share a story. So as you
Sure,
mentioned,
sure.
the vibe coding thing with the grok patterns. So when I started Elastic, when I was getting trained to Elastic, the first task that I was given by my seniors was to generate a grok pattern correctly. It was that back then there was like no chat GPT and all, so we need to figure out how you can, parse the whole big log into a perfect
Yes.
pattern that it will go on. And when I was looking into streams, I was going through the documentation, what was new, what they have introduced. I just one line got my attention, that you can generate your grok patterns. I was like, okay, this is, because it was like, for me, I know how I won't say struggled, but I was very new, and how much time it was taken for me to generate a particular correct grok pattern. So I just go ahead and I started doing it in my Kibana console, and literally there was a generate button. So they have the data index. I click the generate and it generated the grok pattern for me. And to my surprise, it was correct. And even at the accuracy, when it comes to even the larger data set, it's very accurate. Right now, it's only available for Grok, but I am really hoping if they can bring at least few of the more mostly in used processors when it comes to ingest pipelines or losses. Let's say
Yes.
Dissect is very popular. I think it's the second most favorite from like just below the Grok. Still, Dissect is the recommend one, but Grok has been there. It's people's favorite. So if they can introduce for Dissect a bit more for the commonly used patterns, it will be crazy. And one more thing, as you said, the specialty of Elastic is that they listen to their users. Their community is very active, and even Elastic's developer listen to the community, what community is asking for. If they feel that there are certain requirements from the community, and so they will introduce it. So that's why it's kind of a people's favorite platform out there. So yeah,
Yeah, yeah. So to add to that, their active support. One of those days, I know, like I have built across Elastic. I had some experience, and I shared with the team, like just over the LinkedIn, not like raising up a ticket or something like that. And I thought, and it was like one of the top managements of the Elastic. I thought that may not be receiving a reply from them, but I think in like 1.5 hours or so, I just got a reply that thanks for sharing your thoughts with us. I've shared it with the correct development team and the product team to look into this, and if I think they may be introducing that feature down the line. So that's how their support works, and they are quite fast with that. And if you see, I have seen like there are competitors definitely with the Elastic on the NoSQL and SQL databases, but the number of releases that you get and the improvements that over those releases is of a different level compared to the competitors. So yeah, because every release, it's not just an improvement or basically optimization of a certain feature. It's an optimization, but it's an add-on of a new features which are latest in the market and the users need that.
like I'm completely agreeing with you on this. Like, so even if we see the releases for the 9, when it was a major release, it has introduced a lot of feature, and right in the 9.3, they introduced the streams and all. So it's not just like a patch and fixing the bugs. With the late, even for the minor releases, we are getting the new features. So, and right, have you checked out the public calendar? They have rolled out a public calendar.
Yes.
So now it's like you know what we they are doing, and what feature you can like expect from just like one release, or maybe like down
Yeah.
the line in upcoming 3 to 4 months. So with that you can plan it, and it's like I think Elastic is somewhat going back to their open source spirit once again.
Yeah.
It has always been there, but now they are really focused on what the community wants and
Yes.
how they can leverage the both worlds. It's really like feels very
Right.
good.
Right.
There's a solutions out there that listens for your feedback, and they actually roll out if you are pointing to the right direction. So now, yeah, go ahead.
Yeah, please. I have one anecdote on this. I believe going for the open source. When they went open source, I think with 7 dot some version was that. I'm not sure which was 7.6 or something. They said something that it was quite intriguing. That they always wanted to be an open source, but with their current arrangement with the organization, I think they were not able to do. But they built this platform to be an open source, and I'll add something like if you see there are multiple vendors with different technologies. When they say open source, you just get that, you know, the layer which only acts as a minimum viable product for you. Okay, but with Elasticsearch, I think they give you around 90%, 80 to 90% of their stack for you. So that's something huge. People who are using Elastic, they will understand like with their new Apache license, you almost get everything which is there. Like normally you don't get this with other vendors. You definitely need to pay for the main important features. But yes, Elastic has opened it for you, and definitely if you need those features, you can pay for it. But your open source community is always supported by them and thoroughly supported by them.
Perfect. So yeah, now let's talk about the AI enhancement that Elastic is trying to do. So, and I am really interested in what you mentioned, which is the conversational AI that you are working in right now. Can you like give it a more detailed at how Elastic is actually helping because it's a really, you can say, intrigued field. It is something that is gonna boom in the coming future because conversational AI bots is everyone, especially in the
Hmm.
support. So the tech support and your call support industry. So we have seen there was a revolutionary time for, especially in India, when it comes to call center industry, there was a revolutionary era. It was boomed
Hmm.
a lot.
Yes.
And now we have seen so many call centers jobs are replaced by, not actually replaced by, but these bots are taking over a lot because they can be available anytime. So now if I go ahead and I've seen it for every platform. For if I need to have any query in night, back then I got this message, okay, our representatives are not active at this point of time. But now with these bots, you got 24/7 support. So for me, I think it's gonna be a much more bigger field in the coming days, and I'm really want to know that how
Mhm.
Elastic is actually helping you out in.
Okay, so conversational AI is quite a long topic, but I'll try to summarize a little bit of history of it at the start. So, conversational AI, when back in 80s or 90s, it was a rule-based system. Okay, so rule-based means there were rules like if you ask X, the reply would be Y, something like that from a text. Okay, and those were questions were very standard. Then came in IBM, I guess. IBM Watson was the one which basically did that. What do you call it? The groundbreaking thing at that point. And today, what you see as a RAG, a kind of a RAG, it was trying to do with re-ranking algorithms. Okay, and it used to basically, if you ask some knowledge-based questions from it, a question answering kind of a thing, and it was giving you a very precise answer with re-ranking and basically adding few adding data, re-ranking, and basically finding with probability that what would be the best answer for it. So that was when IBM Watson was there. I think they might have brought it the transformer model with it now. So now when in 2017 there was a paper which is called Attention is All You Need. So since I do deep learning a lot, and basically attention mechanism, it paralyzed your process. Okay. And then there was a birth of GPT-2. And after GPT-2, they started scaling the models up to billions and trillions of parameters. And now the models are more fine-tuned with reinforcement learning, and they can basically talk to you in a very human-like manner. Okay, so that's the whole scenario which happened from like past 40 years, but I tried to finish it in 2 minutes. Yeah. So today, when you see as a conversational chatbot, the conversational chatbot should pick up your intent. Okay, what you really need to do with it. Today, if I want my data, so there are a couple of questions like I want to understand my data. That can be done inside the Elastic. Now, now after understanding the data, what is my next step? The next step is to summarize it, provide it as a report, and a further step after that is to generate alerts. And if it is in the software infrastructure, then you can go and fix it, right? But in energy sector, basically things are very hardware like wind farms, solar panels, and all that. You need a technician to go over there, but that's a different kind of a requirement. But if you are like in a telco environment, because telco is now more or less being on cloud, the calling network and all that, so you can have a self-healing mechanism. So basically the conversational bot is at the starting, and when you see these models are basically these are the natural language understanding tools. Okay, they don't do math. Actually, we think that they are doing math, they are doing diagrams, architectures for us, but these are cool these are cool things which are done through tool callings. Okay, but the main aspect of a transformer model is to do the natural language understanding. Okay, so giving the background now, how Elastic is basically the center of all this. So Elastic gives you should the basic application of any chatbot is the RAG, retrieve, augment, and generate. And for the first step of this is basically powered by search. And from the start, I think in 2010, Elasticsearch has been the full text search engine. Okay, so they pick up those roots from there, and they have a couple of algorithms what would like to talk about. There is BM25, which is your text algorithm, basically full text search algorithm. Then they have your ANN and KNN search. They work on the vectors basically, and then they have the RRF, reciprocal RRF. Basically, sorry, I'm not good with the abbreviations, but yeah, RRF is basically using the rank of your BM25 and your ANN search and basically merging them and finding the ranking score. So yeah, so they give you the RRF out of the box. And when I say that you are in the approximate ANN, okay, in that they are giving you that HNSW search. Okay, and the I have written all the abbreviations because I forget them a lot. So HNSW basically it is a hierarchical navigable small world, which is basically an efficient way of doing a nearest neighbor search. Okay, so all these things are packaged for you, like out of the box. You don't need to do the fine tuning on top of it. Okay, so let's say that today uh, I have uh, I have a wind farm site running somewhere in the northern in the North Sea. I have like 150 wind farms over there. Those are connected to an HVDC plant. And from that HVDC plant is basically they are taking the current and basically sending it to the main substation area. Okay, those are the in between. Those are the automation. They have different technological, I would say, black boxes for our audience, like transformers and all that. But you have like 6 to 10,000 IOs running over there. Okay, IOs means your basically your IoT devices, let's say. Okay, so you're picking your 6 to 7,000 metrics from there every second and bringing onto our platform in Elasticsearch. Those are just the logs. Now you have basically you have your metrics. Those are just the metrics. Then you have your SCADA devices, your PLCs. Those are generating your logs at the log NeoJ format or whatever format you have programmed it in. Okay, those are the logs. Now you have the traces. You have the manuals for each and every equipment. You know, each manual is like 150, 200 pages written in multiple languages. And sometimes you are having only native languages over there. And then you have your routines planned on top of that. Okay, so much data. And you want a very intelligent system to collate everything from logs, traces, metrics, your design documents to your manuals to your routines and everything, and bring out the actual information and what is happening if something goes down. So Elastic, what it does is when you're doing the retrieval, it not only basically when it goes to an agentic RAG, it plans that. Let's say I'm asking why the output of my certain wind farms is less. If I say if it let's say if it is 1 megawatt, so if it is only giving me zero point 0.5 megawatt, so I want to understand why it is happening. So is it a malfunction with the hardware? Is it like the weather conditions are not right, or the maintenance has not been done on time? So, but in Elastic, you have everything in it, your maintenance schedule and everything. Now, what the agent does is it plans. It sees your logs first. Okay, it will see your traces. Logs for last half an hour for 24 hours, maybe on 7 days. If there is a trend, when you are bringing those logs or metrics in your Elastic, you can use the ML jobs inside Elastic to do the trend analysis. And
Right.
on the ingestion time, you do that trend analysis. You give that trending score, classification score to that particular timeline that something went wrong at this point. Okay, now actually a chatbot is understanding the data, but you are tagging your data with the ML uh, at the ingestion time. So that is very important for people to tag your data when you're loading it into the Elastic. Then what happens is once your data is tagged, your system basically plans the next step. Okay, this is what is happening. How do I look forward into it? It will do a RAG. It will do that RRF search, bring all the data from your manuals, from your routines, from your maintenance data. It will analyze it in a very large context window of 1 million. Let's say if you have 200,000 tokens, okay, 200,000 tokens are more than enough to analyze such a data. You have a time series data, you have your text data, you have now you are going on a multimodal level. Okay, so this kind of a analysis superpower you didn't have previously. So now once your agent has planned everything, it will give it to a transformer model. You can run it locally, you can have your API key, you can send it somewhere. Okay, this generates, and finally what you get out of that is in couple of seconds or a minute, that after reasoning, and because the weather at the North Sea was not well, not right to generate that certain level of power, so that is why your power level went down. And then it will basically give you the points in the data set. Look at your data at this particular time. You will see, and correlate it with the weather data, you will see that the wind speed has reduced. So has the power generation reduced. It is not because of the maintenance, it is because of the weather in that area. So now that kind of a that kind of an analysis requires people having PhDs, maybe some high level people with a very niche knowledge. Okay, but now with the correct data set, if you have built it on the Elastic, you can basically find everything in one go. And even not just people who are engineers. Think about who are data analysts who don't have an expertise with the wind farm, but they can analyze the data and give it to the management, or management can just explore the data on their own just by conversation. So yeah, I think I've taken much time on explaining this, but yeah, that's how in a
No, no,
nutshell we have implemented it.
so it's kind of a very detailed view, and it's very important to understand that how deep impact it has. And I think to sum it up, I think it's all the difference between a point solutions and the unified solution,
Yeah,
right? So
yeah,
when it comes to Elastic, it's a log storage for you, it's your metric storage, it's your vector database as well, and now you can build your agent in the Elastic itself. So it's the one place to go. As you said, so my logs were also in my Elastic, let's say. My metrics were also there. I did the tagging using my Elastic Anomaly detection. And when I queried, my agent has a very narrowed down view. It has filtered out all the noises, and that gives you the outcome, the accuracy. Because with agentic AI right now, half of the win is only to give the correct data to it. Because if your data is noisy, you won't expect the accuracy to be very much when it comes to noisy data. The more narrowed down, the more clean your data is, the more accurate your result will. And if your everything your data is in one data store, one platform, and because Elastic has done it really well. So what we are talking about, the anomaly detection, it's not the current feature. It was introduced back then, and it has evolved a lot.
evolved a lot here.
It's a very matured solution, so you can rely on it. When
Yes,
I go and see I got an anomaly tagged, I don't need to doubt on it. It
yeah,
has proved itself.
confidence score as well.
So now
Yeah.
it's yeah, completely. So I would like to ask you if you have to give the top three AI related features that Elastic has rolled out till date, what will that be?
Okay, I would like many Elastic uh, product heads will give you very amazing like features which are out of the box, but I'll give you because of the experience. Okay, so today if you will see the AI landscape, they are definitely fighting at the level of models. Like who has the best reasoning, who can do summarization, do the MMLU. Basically, these are some data sets which evaluates your models. Okay, there is one thing what Perplexity did. If nobody, I think, if very few people have seen, they have introduced an embedding model. Okay, you know, embedding, vector embedding is the main thing you need to control in time. Okay, embedding is a vast vector space, I would say a latent space in mathematics, where you basically embed certain data with a lot of vectors, so vector features. Like today, if you have if I say 10 features of your data, like let's say I am a data engineer. This is one feature. I work in AI. This is a second feature. I wear a specs. That's a third feature. I'm wearing a shirt right now. So these are features. So when you have 786 dimensions to represent your data, that is where your semantic search is working. Okay. And you cannot have like Elastic supports, I think 4096 dimensions per document right now, but 786 or 512 is more than enough. Even if you see Andrew NG says that 300 are more than enough. Okay, so what Perplexity did is they did a embedding model for a web scale search, because we need to also see that Elastic is a search engine, and the best one of the best searches right now is being done by Perplexity and Google, Gemini, and all that. But Perplexity, I have seen that people say that it's good for searching. So that web scale searching is because of that embedding model. And and Elastic has its own embedding model that is called ELSER, Elastic Learned Sparse Encoder. Okay, and that comes out of the box. Now, what happens is if you really need to have a good embedding model, and it's a deep neural network, okay, so it has to be trained properly to give you the correct embedding. So you have to pay per token to an API to do your embedding for you. Okay, so today my name is Sauhard. To basically embed Sauhard, you need to pay something. But the vocabulary size is 32,000 for ELSR, I guess that's the one. And you get a perfect embedding model out of the box. Second thing, as an ML engineer, what you can do is you can run your PyTorch and Hugging Face model natively on your Elasticsearch using ELAND and ML nodes. Okay, That's one hidden superpower you don't hear. Okay, I'll come to the main three features, but yeah, this is one thing that people they don't know. Eland is basically a data frame library like your pandas. Okay, and they have their own setup to do it. So now coming to the top three features, one of the top features will be your AI assistant, which where you do the conversational thing. Second, I would rank the ML anomaly models. Okay, because not every time you need a transformer model to do the tagging for you, because running a transformer model requires a GPU. Certain clients are there which they don't have a GPU or they can't pay for the API. But the classical ML models they run on your CPU, and CPU is available everywhere. So definitely they can run on on-prem also. And the size of the models also, like 15, 20 MBs, 50 MB, 100 MB, you can get the classification that you need. So you don't exactly need to mimic the transformer. You just bring yourself down and use the classical anomaly detection, clustering, and population and all that, and try to basically use that. And okay, I am being bit verbose right now, but if somebody would have developed these models from the scratch on Jupyter notebooks, you will realize that you have to load a lot of things. Okay, you have to fine tune your models, you have to do the hyperparameter tuning, and then you do the test, you do the validation, you do the VCs, and you get the best parameters out of it. Okay, but in Elastic you get everything out of the box. You just need to give your data, you need to give your influencers, you need to tell, you can go advanced as much as you want, but definitely if your data is right, you can get everything out of it without going into the hassle of getting into that Jupyter notebook kind of a thing. I'm not saying Jupyter no, I also use it every day. But yeah, Elastic also gives you a very simple interface to do all these. So that is my second best thing. And the third one is basically in Kibana, you can explain your data now. I think in explanation, basically, like that, there are certain things where you can send the data, or you can basically you can do the anomaly detection on top of it immediately. Okay,
Right.
and definitely you have your agentic framework, which comes with the. So three, I think, will be short for me. I would have like four or five, and agentic framework, which I am working with currently. I think that stream feature is amazing, and your agent builder is like you have your data now. Now you have the memory with you because of the Elastic. Now you can play around with it as much as you want.
And also you can export it once you have
Export
built
it.
it. It's not like it will be in your Elastic environment. You can export it via MCP or via web interface. So
Yes.
it's a complete solution out there.
Yes. And there is one more thing on the DevOps side. That's my experience. By my experience, I can tell you that, when you build something on your model environment or dev environment, it is not always the case it will work the same in your production environment. Okay.
100% agreed.
Agreed. So yeah, with Elastic, we had the least number of situations like this. What you have built on the model or on your reference environment, exactly same will be replicated in the production environment if you have followed the steps properly. You won't have any breakdowns, any last minute calls from the SRE teams that this has broken down, that has broken down, nothing like that.
100%. It's like the solution Docker has provided. If it's
Yeah,
running on any machine, it will work in the production. So it's just the same way. If it's working on your lower tier environment, it's a elastic feature,
yeah,
and you have the
yeah,
configuration side, you have the data, it will work. There's no question on. Perfect. I would say if you have to give advice to any, you can say the stakeholders out there or companies and organizations who are looking to have onboarded Elastic. I started to try Elastic. So basically, I want you to give a elevated pitch for Elastic, a small elevation pitch for Elastic, that why you should consider it and what you can expect in upcoming 12 months if you start your Elastic journey now. What transformations you can see in your day-to-day life with it in upcoming year.
yes, okay. So Elastic is basically your Elastic ELK stack with multiple things around it, and the stack has evolved. I still call it as ELK because I started with it as an ELK stack here. So today's people who are looking for who are already on the cloud and they have their cloud vendors with them. They have different data factories over there. They have data proc. They have, I would not should not say the competitor names, but yeah, you have that over there. Definitely, you have multiple solutions out there, but what you get out of Elastic is a very easy way to prototype your thought process. Okay, like in Chat GPT or GPT, you when you sit with Claude or any other product, you use it to conceptualize and bring it to the level where it looks like an MVP. Elastic can do it very quickly for you, and that's just bringing the MVP. Now, the strength of the Elastic. I've worked with a lot of BI tools. I've not seen many BI tools coming closer to Kibana when it comes to real-time analytics dashboards. Okay, when your SQL query is loading, na? Sorry, as a consultant, I'm saying when your SQL query loads from your routine, from your backend SQL databases, the time it takes to process, transform, coming to you and loading, and even if you are loading basically stepwise, like we're only loading the new data, and if you compare it with the Elastic, with the NoSQL database, you will see the difference in speed, the amount of data that is coming through, and the difference in the speed. Okay, and the visualizations are beautiful. You will make beautiful visualizations, very intriguing visualization, eye-popping visualizations. Okay, that's on your cosmetic side, because certain people think that going for other solutions they give you their cosmetic advantage. No, Elastic has its own cosmetic advantage as well. Okay, and Elastic Kibana's, I'm just talking about Kibana right now. Kibana's dashboards are built for time series databases. Okay, they
Right.
have these static databases, but the newer additions on the Kibana, they are built on time series. Like some of our services, we can exactly find when they started, when they become stable, when there was a fault, when the fault triggered a breakdown of the service, and the affected. Everything comes on our timeline. Like that's like you don't need to build a timeline, it's already built for you. So that's with Kibana. Now coming at the workhorse, the Elastic engine, the Elasticsearch, and you can use it as a search engine. You have your analytics built in, you have your aggregations, you have a very vast and powerful ESQL now. Now people used to say that DSQL is difficult to write because of the queries and all that, but DSQL was still very, very efficient. If you see other languages, DSQL used to give your a lot of power to your hand to find the exact data, because if you're building search applications on top of Elasticsearch, it was the go-to. Now you have the ESQL on top of it, and you can do with ESQL, we do enrichment on real time. Okay.
Right.
Okay, so we have exploited that feature as well a lot on our dashboards. Like if you want to tag some of your data on time, and normally what people do is they will tag the data for entire week. That's a gigabyte of data, okay, TB of
Right.
data, tagging it unnecessarily. What we do is whatever you want to see, you enrich it on the fly because of the in memory, and you just see all your data without any breakage. Okay, and okay, you have your ILM policies to control your data. You have data tiering. Okay, you have vector search, semantic search. People will be thinking Pinecone. You have your observability in at one place. You have your vector search at one place. You have your semantic AI at one place. You have your dashboards at one place. So connecting everything together, okay, and bringing all that data together, and that is the power of Elasticsearch. And when you are basically, my advice to you is, when you are bringing an Elastic Stack, start building immediately. Okay, when you will bring your data immediately, you will have that knack. Okay, now what can I do, what can I do, and you will start exploring Elastic as a search first, then aggregations, then analytics, machine learning. And once you start reaching to that solution space, what you're looking for, you will understand that Elastic offers a lot which other products are still offering you at a narrow and at a price band. Okay, you should also see the price band. Like when I'm saying the embedding has a cost, running models has a cost. Okay, and when I say you can run PyTorch and Hugging Face just on the ML nodes, you are basically saving on the infrastructure cost as well. If you're not going into the GPU, if you're just using the CPU models, on the PyTorch, basically you are basically saving a complete cost on building the infrastructure and maintaining it, because you just need to maintain the EL nodes over here. And there is one more thing about the open source data structure stack these days. People want to add a lot from the open source. They should understand something. The Logstash is quite fast. You have beats, you have metric beats, everything is bringing you the data. The more the open source you add, I'm not against the open source, I'm actually for the open source, but I've seen architects bringing multiple things into it, and it complexes your environment and increases the dependency. And with Elastic, you are open source, but there are the dependencies are very less. So yes, and it can scale to TBs. We do TB of writing of data every day, and it works perfectly. And then seconds you can find your data. Second, millisecond searches we have. So yeah, I would say just build on top of it and start from the scratch. Get yourself your data AI ready first of all, and then build on the complex products.
Yep. I mean, yeah, it's like what we said. It's not a point in solution. So
Yeah,
once you start working with it, you will see it's not a search. It's not just a search engine.
yeah,
Elastic can do data engineering analytics for you, as you said. You can build AI agents on it. You can do it. You can utilize it very, very much for your observability. You can use it for your SIEM analysis as well. So it
yeah.
has a complete package to offer right under one umbrella. And
Yes,
it's we are just talking about the Elasticsearch as a platform, and when it comes to the other shippers and all, as you
yeah,
said, ELK stack, when it comes to whole stack, there's a lot to offer. So it's high time that anyone, if you are not using Elastic, please give it a try.
yeah.
And there is a free trial available for Elastic's cloud services. So you don't even have to do anything,
Basically,
install it on VMs. You can just go and
and yeah,
let's say free trial, try it for
connect.
15 days, and you can just and we can guarantee you will fall in love with it because we
Yes,
had, and you will as well. So yeah,
yes.
it's a
And
complete package and it's a great product. Yeah, go
yes.
ahead.
And we only spoke, I think in this podcast, we only scratched the surface for Elastic, and we
Yeah,
did not even go into the enterprise search. That's a different product altogether, basically bringing everything together. And that's also you can integrate with your license and yeah. And we have like data streams. We could like there are multiple things I can talk about, like how logsdb is basically compressing your data. Definitely, you have. As a conclusion, I would say that Elasticsearch is not the only NoSQL database in the market. But if you see the offerings with the Elastic, there is no other product also which is giving you so many things at a competing performance at giving you 80% of it as an open source and basically giving you the best features. Like you might have tried multiple, they might have tried the multiple open NoSQL solutions, but Elastic, either someone is lagging a complete dashboarding tool, you connect with some other dashboarding tool, it doesn't work properly. They connect with some other data ingestion tool. The data ingestion is basically becoming the bottleneck. Their NoSQL database comes, the story is different with that. Now they are only fighting with the ingestion to bring in the data because two things they don't talk to each other properly. But in Elastic, you have everything integrated. It's like what Steve Jobs said, if you want to really build your software, you need to control your hardware. But if I connect this analogy with the Elasticsearch, if you really want to make a good data platform, you have to control every aspect of it, like from ingestion to transformation to your to machine learning to your dashboarding. Everything is integrated, and that's how it should blossom.
it's not just a single product; it's an whole
Yeah,
ecosystem that you
whole
get.
ecosystem. Yes.
And yeah, I think we just the last question I want to ask. It's kind of just a yes and no question. We have scratched the surface. We know the answer, but let's say someone just jumped to the end of the video and just want to see the what you say gist and the whole outcome. So is it safe? Is it true to say that Elastic is not just a search engine anymore? It has evolved drastically. It is a lot to offer. It's not just what it started as a search engine, but it's not just a search engine anymore.
Okay, for those people who basically jumped at the end of our video, welcome. You are a very interesting person. So, yeah, you can look at our whole conversation. It is very intriguing. And yes, if you see that Elastic is definitely not a single search engine, I would say a solution as a search engine. If you're looking for that, maybe there are better alternatives. But yeah, the capabilities around the search engine which Elastic provides, the Lucene, the backbone, the Lucene searches, the BM25, the full text search, and doing it at a very competitive response time. That is just the search engine. But now around that you have multiple things which Elastic has built for you. So no, Elastic is not a single just a search engine. It's the now the I would say that I've written that line somewhere. I have written it. I'm not able to exactly find it out. And it's like a punchline. So it's not just your search engine. It's like a brain now, the AI brain for you, where you store, where you basically, it's like a memory. So if your agentic AI is not having any memory, it's just a transformer model, which is basically where you are just activating weights and getting a response out of it. But if you have a memory attached to it, so you have an amazing system which can actually be a second brain for you, or like an assistant for you. Okay. And Elastic, when you're building that kind of a capability, Elastic gives you that observability. Okay, that level of observability. So you're not just building, you're observing, you're monitoring that thing, how well it is performing, and you are getting everything in just one package. So yeah, that's the best, one of the best deals out there. Just go and grab it, start building on top of it. Use the LangChain with it, build products on top of it. You will start falling in love with it, and you will definitely be one of the most satisfied persons, I would say. Yeah,
Awesome. So
yeah,
thank you, Swad. It's been a really great conversation. I think I have learned a lot. I hope for the same for our viewers. And
yeah.
thank you very much for the time. And for our viewers, you have heard Kibana data analysis a lot in this podcast. We do run a Kibana in Action series on the same Hyperflex channel. You can go ahead and watch that. We have covered not in that detail, but you can start just by seeing our videos that what we can achieve using Kibana. We do host a monthly webinar where we try to feature one feature or one enterprise feature of Elastic and go in depth on it. And you can follow us on our social media handles. You can follow Sauhard on his social media handles. And till next time, see you there. And please go try Elastic. You will fall in love with it. Thank you so much.
Thank you for having me here, Parvesh. Thank you, Hyperflex, for giving me this opportunity. I hope we can have more conversations like this, and all the best to you. I had a
Thank
really
you.
good time. Thank you. Okay, take care. Bye.
Okay, bye bye.
Bye.